Afternoon, good evening. This is Math 123 Quantitative Reasoning, um, October 2nd. Oh, this class is for October 6th, Monday, October 6th, and this is chapter 13. Okay, chapter 13, we're going to talk about measurements and conversion rates. Let's start out with something simple. How many days are there in 6 weeks? And the answer, as you may have figured, 42 days, which is basically 6 times 7, which then answers this question. How did we get to that? 7 days in a week times 6 weeks. 6 times 7 is 42. So you're using an algorithm to develop this 7 days times 6 weeks. An algorithm is basically a step-by-step procedure. We're using it here to find the number of days given a number of weeks. So we wanted an algorithm that gave us number of days and a given number of weeks. It would just be multiply the number of weeks by 7 days. There's also something called the factor label method. And this is basically what you're doing is multiplying your initial value by 1. Multiplying anything by 1 gives you the same answer. So you're not changing the value of what you have. So if you look at this here, since 7 days equals 1 week, you can create two identity ratios. Identity ratios are numbers that equal 1. 7 over 7 equals 1. 1 over 1 equals 1. 5 over 5 equals 1. So 7 days over 7 days equals 1, which means 7 days over 1 week also equals 1. And then 1 week, which is 7 days over 7 days, also equals 1. So even though there's different numbers, 7 days over 1 week is still 1. You're dividing the same thing by itself, that equals 1. Okay, so let's look at this example here. You want to select the identity ratio, which makes sense for the given situation. So look at example 1. So we have 16 weeks. We want to convert that into days. You do 16 weeks over 1, because 16 weeks is the same thing as 16 over 1, times 7 days over 1 week. You can then cross out the weeks. So the weeks are gone. You have 16 times 7 over 1 times 1. So 16 times 7 days over 1 times 1, which is 16 times 7 over 1, which equals 112. One way to kind of think of this is if you think of this right here, 16 weeks times 1 equals 16 weeks. 16 weeks times 7 over 7, that's 16 weeks times 1 again, still equals 16 weeks. 16 weeks over 7 days divided by 7 days, again, 16 divided by, or times 1 equals 16 weeks. So all you're doing is you're saying 16 weeks times 7 days over 1 week equals 16 weeks, because these are the same. 7 days over 7 days equals 1. 7 days over 1 week equals 1. So 16 weeks times 7 over 1, or sorry, 7 days over 1 week, that's 16 times 1, 16 weeks. So even though one is weeks and one is days, they're equivalent. So dividing one by the other equals 1. So it's the same thing as this here. And now what you want to do is you want to set it up so that you have weeks on the bottom on one and weeks on the top on the other, because then they'll cancel out. So then you're just left with 16 times 7 days divided by 1 times 1. So 16 times 7 days equals 112 days. So this might be something that doesn't resonate immediately, but as you start doing them and you start thinking about it, it might make a little more sense. Okay. Let's look at example two. An average pregnancy is 280 days. How many weeks is this? So we want to do, oh, you're cheating. Stop. We want to use that same thing, weeks and days. So 1 week, 7 days, because you want days to cancel out. So you want days on top here, you want days on the bottom here. That gives us 280 days times 1 week divided by 7 days. These will cancel out. Just strike through button. So now you just have 280 times 1 week divided by 1 times 7. So 280 divided by 7, which equals 40 weeks. Okay, let's move on. All right, another conversion. Horses are measured in hands, and 1 hand equals 4 inches. What are two identity ratios? We're starting with the basics here before we solve anything. What are two identity ratios that can be created from 1 hand to equaling 4 inches? Well, we're going to have did I delete this? I'm sorry. There we go. So we have 4 inches over 1 hand. We have 1 hand over 4 inches. So it's important to make sure you have the labels. You can't just put 1 over 4 or 4 over 1. You have to say 4 inches, and you have to say 1 hand. With any of these, you always have to label any number. Otherwise, you can get confused. You could put something in the wrong spot. According to the Guinness Book of World Records, the world's tallest horse, Big Jake, is 20.6875 hands tall. Let's convert this to inches. As you see, 20.6785 hands. We have 4 inches over 1 hand, which is this one right here. Hands cancel out. Oops. So we have 20.6875 times 4 divided by 1 times 1, which gives us, oops, 82.75 inches. The world's shortest horse, Thumbelina, is 17.5 inches tall. How many hands is this? We're going to set it up the same way. Seventeen and a half inches times 1 hand over 4 inches. This time's inches, we're doing 1 over 4 because we want inches to be on the bottom here because it's on the top here. So since we have inches divided by inches, those cancel out. We have 17 and a half times 1 hand divided by 4, which equals 4.375 hands. Right. The average Clydesdale is 18 hands tall. Clydesdales are big horses. 18 hands. So then we want to have hands on the bottom over here. So that way they cancel out. So we have 18 times 4 inches divided by 1. This gives us 18 times 4, which is 72 inches. So notice the label that's not canceled out, the measurement that's not canceled out, inches, goes in the answer. So hands gets canceled out because you have hands divided by hands, so that's gone. Inches is left by itself. So it's important to make sure you follow that so that you have the right number over the right number and don't have them switched. Okay. Let's talk about the US system. Okay. We have all these systems that you're probably accustomed to, but a lot of you probably don't know how many pints are in a gallon, how many pints are in a quart, the quarts are in a pint, how many ounces are in a cup, et cetera, et cetera. So we have this chart. Okay, so we want to change 27 feet to yards. Now, normally you would just take feet and divide by 3. Makes sense to get yards, but we want to set it up the right way. So we want to use 1 yard over 3 feet, because that way feet cancel out here. So we have 27 times 1 yard over 3, which gives us 9 yards. So when you would do this in your head, you would just do 27 divided by 3, but doing it like this ensures you don't make a mistake and multiply by 3 on accident instead. And then when we get to longer questions that require more than one conversion, it's better to have all this stuff written down so you don't mix them up. 15 yards to feet. You want to use 3 feet over 1 yard. That way the yards, you have yard over yard. That cancels out. 15 times 3 feet equals 45 feet. The world's record for hair length is 221 inches. How many feet is this? We want to use 1 foot over 12 inches so that the inches cancel out. We have 221 times 1 foot divided by 12, which gives us 18.4 feet. If you canned 18 quarts of tomatoes, how many gallons would this be? We have to look at our chart. Quarts to gallons, 4 quarts in a gallon. So we're going to want to use 1 gallon over 4 quarts because we want quarts to cancel out. So we have quarts, 18 quarts divided by quarts, which leaves us with 18 times 1 gallon divided by 4, which is 4.5 gallons. Okay, now we have a conceptual problem. Which weighs more, a 2.5 ton truck or a 3,500 pound hippopotamus? So we want to figure out how many pounds 2.5 tons is and see if that's more or less than 3,500 pounds. All right, so we set this up. 2,000 pounds over 1 ton. That way tons cancels out. So we have 2.5 times 2,000 pounds divided by 1, which equals 5,000 pounds, which is more than a hippopotamus. So the truck weighs more. Truck weighs 5,000 pounds. The hippo weighs 3,500 pounds. Okay, more examples. Okay, so now we're going to start doing examples that have multiple parts. And this is where it's very important to make sure you label everything. You want to make sure that what's up here is down here so that it cancels out. And then you're going to have pints here, pints down here, cups down here. That way stuff keeps canceling out. So the only thing that's left is this measurement here, this label. Okay, so converting 1 gallon to an ounce, so you do 1 gallon equals 4 quarts over 1 gallon. Gallons cancel out. Then you have 2 pints over 1 quart. Quarts cancel out. 2 pints over, or 2 cups over 1 pint. Pints cancel out. 2 cups over 1 pint, and 8 ounces over 1 cup. Cups cancel out here. So everything kept canceling out this way. So we are left with the only measurement left is ounces. So we have 1 times 4 times 2 divided by 1 times 2 divided by 1 times 8 divided by 1 ounces. So 1 times 4 times 2 times 2 times 8 equals 120. Okay, so you can do this individually, do this part, gallons to quarts, then you can get an answer, then you can do quarts to pints, get an answer, then pints to cups. You can do each part individually, but you may as well just set up the whole thing, cancel out, crosswise here, so it's a little bit faster. You only have to punch in your calculator once. All right, then here they're saying, well, if you know 1 quart equals 32 ounces, you can skip a step and go quarts straight to ounces. So it's still the same thing. 1 gallon times 4 quarts over 1 gallon. Gallons cancel out. 32 ounces over 1 quart. Quarts cancel out. So you have 1 times 4 divided by 1 times 32 divided by 1. Still gives you 128. Okay. Math 123 lasted 14,000 seconds this week. How many hours is this? Fill in the identity ratios, cancel units, and solve. All right, so it's already set up seconds. We got seconds on top here, seconds on the bottom here, minutes on top here, minutes on the bottom here. All right, so 1 minute to 60 seconds. 1 hour to 60 minutes. Seconds cancel out. Minutes cancel out. We are left with just hours here. So we have 14,000 divided by 1 times 1 divided by 60 times 1 divided by 60 hours, which leaves us with 3.89 hours. Right. If you cooked 3 quarts of soup, how many cup-sized containers will this fill? So you have to look back at this, unless you know these by heart. And you want to set it up so that quarts, you have quarts over quarts, those cancel out. Now you have pints over pints. Those cancel out. We're left with nothing but cups. So 3 times 2 divided by 1 times 2 cups. That gives us 12 cup-sized containers. Gives us 12 cups, which is 12 cup-sized containers. If we had a measurement in inches and wanted to convert it to miles, what steps would we take? Well, you're going to want to convert inches to feet and then feet to miles. So 12 inches in a foot, 5,280 feet in a mile. Is that on this list? No, it is not. Oh, yeah, it is right there. Okay. Well, hold on. Yeah, that's right. Okay, because you go feet to inches to feet, feet to miles. You don't have to go through yards because yards, we have the conversion directly from inches to feet. Or I'm sorry, feet to miles. All right, so you're probably all used to the English system, and nobody wants to convert to the metric system. They've been trying to convince people to switch to the metric system since before I was in elementary school. But Americans don't want to do it. The good thing about the metric system the metric system is that everything is 10 bigger than the next. So you have 1,000. So everything's measured in kilos, hectos, deca, deci, centi, and milli. So you have kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters. You're probably familiar with millimeters and centimeters and kilometers, but hecto and deca and deci are also in there. So that everything is, each unit is 10 times bigger or smaller than the one above it or below it. So the metric system should be easier to use because you can just move the decimal. So let's look at some examples. Oh, the mnemonic device, King Henry doesn't usually drink chocolate milk, can help us remember the leading letters of those common metric prefixes. Kilometers, hectometers, decameters, the unit, the regular unit, decimeters, centimeters, millimeters. But you're probably familiar enough with kilometers, meters, centimeters, and millimeters. You just, the hecto and the deca and the deci are the ones you kind of got to learn. Okay. So one way to convert is to do as we were doing by using those identity fractions, identity ratios. So if you want to move 10 meters is one decameter. So 10 meters over 1 decameter or 1 decameter over 10 meters. I'm not sure if I'm pronouncing decameter right. I've not used much more. I've not used anything other than kilo, centi, and milli. Anyways, okay, example, centimeter is 1/100th of a meter. It means there are 100 centimeters and 1 meter. So you can do meters to decameters and decameters to, oh, that's the wrong way. Decameters. You'd go meters to decimeters to centimeters, or you can just go meters to centimeters. All you need is this here. So with this, you don't need to do multiple conversions. You can go straight to the one of interest. So if you want to go from meters to centimeters, you divide by 100. You want to go from hectometers to millimeters, you're going to divide by 1,000 and also divide by 10 and then divide by another 10. I'm sorry, you just divide by 100, then divide by 1,000. We'll get to some examples of this. Okay, let's move down. We're going to start at the basics. A kilometer is 1,000 meters. What identity ratios can be made with this information? So 1 kilometer over 1,000 meters or 1,000 meters over 1 kilometer, depending on which way you're going. A millimeter is 1,000th of a meter. What identity ratios can be made with this information? 1 meter over 1,000 millimeters or 1,000 millimeters over 1 meter. And you would use whichever one depending on which way you were going. All right, let's look at an example. The average racehorse weighs 500 kilograms. How many grams is this? So you would set it up like this. 500 kilograms times 1,000 grams over 1 kilogram. That way these cancel out. So you have 500 times 1,000 grams. Oops. 500 times 1,000 grams divided by 1, which equals 500,000 grams. Convert 2,500 centimeters to kilometers. Okay, so this one they're going centimeters to meters, meters to kilometers. So the centimeters, these cancel out because you have centimeters divided by centimeters. Then you have meters divided by meters. So you have 2,500 times 1 divided by 100 times 1 kilometer divided by 1,000. You run that through your calculator, you get 0.025. So 2,500 centimeters is 0.025 kilometers. And you could kind of spot check this, or do a simple, think about this. A kilometer is almost a mile. I think it's 2/3 of a mile approximately. Um, so it's big. And then a centimeter, there's 2.5 centimeters in an inch. So what's that? 30 centimeters in a foot. So there's not going to be a lot of centimeters in a kilometer. So 2,500 centimeters is probably still well short of being a kilometer. Okay. Because metric to metric conversions result in multiplying or dividing by powers of 10, another method of converting from one unit of metric measure to another is by moving the decimal point. This is why the metric system is supposed to be so much better than the English system, because you don't have to multiply by 8, multiply by 2, multiply by 4. Everything's 10, 10, 10, 10. So you can just move the decimal to the left or to the right. So for this one, converting 5.2 kilograms to milligrams, you look at the chart here: kilograms, hectograms, decagrams, grams, decigrams, centigrams, milligrams. You just keep moving the decimal point. So 1, 2, 3, 4, 5, 6. So you're going from here. So the decimal point was here. We're going to go 1, 2, 3, 4, 5, 6. So the decimal point is here. So the decimal point was here. We moved it 6 times. 1, 2, 3, 4, 5, 6. Now the decimal point is here. So 5.2 kilograms equals 5,200,000 milligrams. So you just need to know. So that's why. So this is 5.2. You then move it 1, 2, 3, 4, 5, 6. Whoops. Decimal points here. You move it 1, 2, 3, 4, 5, 6. So you have to add all of these zeros. That's how you go from 5.2 kilograms to 5,200,000 milligrams. So the decimal point starts here. You put in zeros as needed. 1, 2, 3, 4, 5, 6. So this is just the chart that we have right here. So they took this chart and you're moving the decimal point one past a zero or past a number every time you go from here to here to here to here to here to here to here. So this is just the list: kilo, hecto, deca, the unit, grams, deci, centi, milligrams. So this is where that mnemonic device comes in. King Henry doesn't usually drink chocolate milk. King Henry doesn't usually drink chocolate milk. So by using that, you can just move this way, or if you're going to a bigger unit, you would go this way. All right. Let's convert 24 milliliters to liters. All right, so you start here. This is your milliliters. So you have 24.5 milliliters. So the 5 doesn't have a label because it's less than a millimeter. So here's your milliliters, so 24.5. So the decimal's here. you need to go to liters. So you're going to go 1, 2, 3. So now you're at 0.0245 liters. So this little chart helps here. And you also want to think about this after you get your answer to check to make sure you went the right way. For example, 24 milliliters. A milliliter is a tiny unit. You give medicine in milliliters. You give your baby 5 milliliters of medicine. So it's a tiny little, it's less than an ounce. Whereas a liter is a half of a 2 liter. So if you have 24 milliliters, that's going to be a small fraction of a 2 liter. I guess think of it that way. So you kind of want to check your answers logically in your head from what you know. You know that a 2 liter is, a certain size. Half of a 2 liter is still, pretty big. And then a milliliter is a little tiny, probably 4 or 5 drops. So you know that 24 milliliters is going to be much less than 1 liter. So you should get a fraction of a liter. Okay, let me see here. Okay, so this one, we got, so we're moving milliliters is how many kiloliters. You're going to start here and you're going to go 1, 2, 3, 4, 5, 6. So you're going to have to add a 0 here, here, and here. And then your decimal point is now going to be right here. So you're going to have 0.0000245, 0.0000245. All right, so 24.5 milliliters is how many centiliters? You're just going to go one over, right? Because you're going from here to here, so it should be 2.45. Oops, I need the answer too. All right, so you're just moving to go from milliliters to centiliters. You're just going from here to here. So the decimal sits right after the milliliter. And then you go 1 over, so the decimal's right after the centiliter. So 2.45. It can be easy to get mixed up here, but just do it slowly and, practice. The more practice you have, the better you will do. Okay. Converting within the metric system. Okay, let's do some examples within the metric system first to start off. If a wine barrel holds 119 liters, how many milliliters is this? So we're going to have to go liters. So we're right here. We want to know milliliters. So we're going to have to add 1, 2, 3 zeros. Yeah, because it's 119.0 liters. So you're going to do 119, move the decimal to the right 1, 2, 3 times, which gives us 119,000 milliliters. So you have to imagine the decimal is there. So this is really 119.000 liters. You need to move it 1, 2, 3 times to 119,000. And this chart is helpful right here. Actually, this helps a lot to make sure you're going the right way. Okay, hair grows an average of 15.24 centimeters per year. How many decimeters is this? So we're going centimeters to decimeters. So we're going to move the decimal point from here, centimeters, to the left one to decimeters. So it's just one move to the left for the decimal. So 15.24 centimeters, move this to the left to here, becomes 1.524 decimeters. How many meters is this? So we have 15.24 centimeters to meters. So we're sitting right here at centimeters. 2 decimals to the left. That gives us 2 to the left, 2.1524 meters. All right, how many millimeters? So I'm going centimeters to millimeters. So we're right here. To go to millimeters, we have to go to the right. So we're going to move the decimal once to the right. Oops, I didn't get the whole thing. There we go. There we go. So 15.4 centimeters, you move it once to the right to here, 152.4 millimeters. So you just want to use this chart and you want to move the decimal to the left or to the right based on, you put the decimal where you're starting at and you move it to where you want to end. So it should be at the right, bottom right corner of the box where you start. And then it should be at the bottom right corner of the box where you're ending. Okay, let's move on. All right, converting between US and the metric system. So this gets a little trickier. Obviously, with the metric system, you can just move the decimal, but now we're back to doing the identity ratios again. Because 1 inch is 2.54 centimeters, 1 yard is 0.9144 meters, mile is 1.6 kilometers. It's quarts to liters, kilograms. Yeah, a pound is, I'm sorry, a kilogram is 2.2 pounds. I know that. And that's what 1 over 0.4536 would be 2.2. Okay, so each line in here can be used to create an identity ratio. Okay, so this is what I just said. I gave the answer away. There's just certain things I remember: 2.54 centimeters in an inch, 2.2 kilograms in a pound, or 2.2 pounds equals 1 kilogram. So a kilogram's heavier than a pound. An inch is bigger than a centimeter. Yards and meters are approximately equal, but a yard is slightly smaller. I think a meter is 39 inches. A yard is 36 inches. And then this I remember because 3.1 miles is 5 kilometers. Because if you'll see like in track, there's the 5K. The 5K is 3.1 miles. So that comes out to 1 mile equaling 1.6 kilometers. Okay, back to example 1. Okay. Convert 2 inches to centimeters. You set it up just like we were doing before. 2 inches times 2.54 centimeters over 1 inch because you want inches to cancel. Inches divided by inches. So now you have 2 times 2.54 centimeters divided by 1, which equals 5.08 centimeters. 24 centimeters to inches. 24 times 1 inch over 2.54 centimeters. And the centimeters cancel out. You have 24 times 1 inch divided by 2.54, which gives you 9.45 inches. All right, now if you want to convert 254 centimeters to yards, you got to do a couple of steps based on the information we have. 245 centimeters times 1 inch over 2.54 centimeters times 1 foot over 12 inches times 1 yard over 3 feet. So now everything cancels out again. Feet cancel out, inches cancel out, centimeters cancel out. So you have 245 divided by 1 times 1 divided by 2.54 times 1 divided by 12 times 1 yard. So you end up with 2.68 yards. Right, then they have an alternate way that just uses a different couple of steps. You're still using the info from that table. This just has one less step. This goes centimeters to meters and then to yards. Just make sure everything cancels out. Meters cancel out here, centimeters cancel out here. You're left with just yards. Because you're starting at centimeters, you want to end on yards. Okay. Converting between US and metric systems. Okay, let's do some examples. Guests at a party consumed 50 liters of wine. How many gallons is this? So we want to go look at how many liters. I think we have liters to gallons, right? Oh, no, we have quarts. Yeah, quarts. We have quarts to liters. All right, so we have liters here, which cancels out the liters on the bottom here. Quarts on top here, which cancels out the quarts on the bottom here. We are going from liters to gallons. We have gallons left over. So 50 times 1 divided by 0.9464 times 1 gallon equals 13.21 gallons. So we had to use both charts here. We had to use the liters to quarts and then also the liters to gallons. I'm sorry, liters to quarts and then quarts to gallons. So we had to go back to this one. Where is it? Right here, liters or quarts to gallons. And then once we have our gallons to quarts, and then we wanted to do, quarts to liters. So gallons to quarts and then quarts to liters. Sorry, that was a lot of scrolling, but you need to use both charts for this example in order to figure this out. Okay, pounds to kilograms. I believe this is a direct conversion. Yeah, so 200 pounds times 0.4536 kilograms over 1 pound. Pounds cancel out. So 200 times 0.4536 kilograms equals 90.72 kilograms. So about 91 kilograms. Okay, here we go. Who is shorter? James Madison, the shortest U.S. president at 5'4", or Napoleon? Not Napoleon Dynamite. Napoleon, the French commander from the 1500s or something. Okay, so we want to convert inches. First of all, we want to turn 5.4 into inches. We probably want to turn 5.4, 5 feet 4 inches into 5.33. Let's see what we want to do here. Hold on. So we're going to inches to centimeters, then to meters. Okay. So we got to turn 5'4" into inches. So 5 feet, 5 times 12 is 60, plus 4 inches is 64. So James Madison is 64 inches tall. Then we want to turn inches into centimeters using that conversion table. Set it up so the inches cancel out. We now have 64 times 2.54 centimeters divided by 1, which is 162.56 centimeters. or 1.63 meters. So going from centimeters to meters, you go centimeters, decimeters, meters. So that's why you move it twice. So you're at centimeters, you go to decimeters, and then meters. So 1.62. If you're not follow right with your eyes right now, follow my cursor. You're here at the decimal at centimeters. You want to go 1 over to decimeters and then to meters. So you move the decimal point to here, 1.6256 centimeters. So 1.63 meters, that is how tall Madison is. So Madison is shorter than Napoleon by 0.06 meters. All right, if you purchase a loaf of artisan bread weighing 700 grams, how many ounces is that? So we use our grams to ounces conversion. We do 1 ounce equals or over 28.3495 grams. So the grams cancel out. We have 700 times 1 ounce divided by 28.3495, which gives us 24.7 ounces. Okay, your cousin's newborn baby, 6 pounds, 7 ounces. How many kilograms is this? So first thing you need to do is do pounds to ounces. So let's do 6 pounds times 16 ounces. Oh, 6 pounds times 16 ounces divided by 1 pound. Pounds cancel out. We have 96 ounces. 96 ounces is just for the 6 pounds. We need to add the 7 ounces on top of that. So now we have 103 ounces. Then we want to do the metric conversion. 103 ounces times 28.3495 grams per ounce. Let's see, ounces cancel out. So we have 103 times 28.3495 grams divided by 1 equals 2,920 grams. Now that we have grams, our grams are right here. We want to go to kilograms. So we go to decagrams. Oh shoot, what are they? I can't remember these. Yeah, so decagrams, hectograms, kilograms. So we're here to decagrams, hectograms, kilograms. So we move the decimal to after the 2. So we have 2.92 kilograms. Your cousin's baby weighs 2.92 kilograms. All right, I know I'm not there, but let's take a 5-minute break. And I'm just going to sit silently for 5 minutes. You all can get up and go to the restroom, and then come back. Just meet back in 5 minutes. I will restart in 5 minutes. All right, let's get started again. All right, we're starting back up. Okay, so now we're going to look at rates. Rates are a little bit more complicated because it's not just 35 miles, it's 35 miles divided by 1 hour that you're starting with. So in order to convert, you're going to need to do multiple changes to the top and bottom of the fraction. So, all right, so starting at 35 miles per hour, how many feet per minute is this? So first we got to change miles to feet. So we put in our 5,280 feet per 1 mile. Miles cancel out. Then we put in our 1 hour to 60 minutes. And then hours cancel out. Even though they're still canceling out, hours is on top here, that's on the bottom here, even though they're a little farther apart than we're used to seeing. Miles cancel out, so miles here, hour on the bottom here, hour on top here. So now we have 35 divided by 1 times 5,280 divided by 1 feet per minute. So we're left with feet over minutes, which is what we want. We want feet per minute. So that gives us, when we run that through our calculator, 3,080 feet per minute. So it's the same concept. You just have to adjust two metrics. So miles has to go to feet and hours has to go to minutes. So we know how to convert all those. We just got to set it up correctly. So miles on top here, miles on the bottom here, hours on the bottom here, hours on top here. And then you're left with feet divided by minutes, which is feet per minute. Okay, let's continue on. Soccer player can kick a ball 122 kilometers per hour. How fast is that in miles per hour? All right, so we want to start with the 122 kilometers per 1 hour. And we're staying at hours, so hours can stay, but kilometer has to cancel out. So we have 122 times 1 mile divided by 1 hour, miles per hour. That's what we want. We want miles per hour at the end, miles over hours. So run this through your calculator. 122 divided by 1 times 1 divided by 1.6093 equals 75.8. All right. Resting heart rate is 70 beats per minute. How many times will it beat in an hour? So let's 70 beats per minute. We want to get out, we want to be left with just hours, beats per hour. So we set it up like this so that minutes cancel out. And then we're left with beats per hour, beats over hours, beats per hour. So now we have 70 divided by 1 times 60 divided by 1. And that's beats divided by hours, which is beats per hour. Fastest horse race ever recorded ran 70.76 kilometers per hour. Well, the fastest racehorse ever recorded ran 70.76 kilometers per hour. How many meters per hour is this? All right, set it up. 1,000 meters to 1 kilometer. Kilometers cancel out. So now we have meters divided by hours. Run this through the calculator, 70,760 meters per hour. You buy a pump that is rated 2,500 gallons per hour. How fast can it pump in liters per minute? All right, now we got to convert 2 gallons to liters and hours to minutes. So we start out with our 2,500 gallons per 1 hour. Multiply by 4 quarts to 1 gallon. That way gallons cancel out. And then we do 0.9464 liters per quart, per 1 quart. That way quarts cancel out. And then we want minutes at the end. So we want to have minutes per minutes, not per hour. So we do 1 hour divided by 60 minutes. That way hours cancel out. And we are left with liters divided by minutes, which is liters per minute, which is what we want. So we want to have the end result when you're doing these is you want to have liters on top left over and then minutes on the bottom left over. So we have liters over minutes, which is liters per minute. Run this through the calculator. You end up with 157.7 liters per minute. Okay. Applications with the rates. Now we will solve application problems by applying a rate to a given value to solve for a value with the desired units. The speed limit on some highways is 65 miles per hour. Think about what 2 conversion ratios you can make from this information. 65 miles over 1 hour or 1 hour over 65 miles. Now let's see how we can use this. It's 120 miles from Lafayette to Fort Wayne. If someone travels an average speed of 65 miles per hour, how long will the trip take? Question asks how long, so we want the result in what unit of measure? It's time. We want to have a time. How long is going to be time? Hours. Okay, so 120 miles. Then we plug in our, 1 hour divided by 65 miles. So we get 120. So miles cancel out. So it'd be a lot easier if I was there. I could cross the miles out with the pen and the TV, but that's okay. So 120 times. So first of all, let's look at this. The only thing we're left with is hours. So miles was completely canceled out. We're left with hours, which is what we want. We want hours to be the only measurement left because that's what we want. We want how many hours will it take to get from Lafayette to Fort Wayne. So we have 120 divided by 1 times 1 divided by 65. Run that through the calculator. And we have 1.85 hours. How long will the trip take traveling 55? Just do the same thing. But this time, use 55. Set it up the same way. So the miles cancel out and we're only left with hours. Shoot. So we just have hours left over. 120 miles. 120 divided by 1 times 1 hour divided by 55 equals 2.2 hours. All right, so it's the same setup. You're always using these identity ratios. You're always multiplying by an identity ratio, but the end result is you want the units, the unit measurements, the unit labels left that answer the question. So in this one, we want hours, we want time left. We want to get rid of miles entirely. So we want to make sure miles are gone. Okay. And the other questions above, we wanted to keep, minutes per, meters per minute or something. So you always want to keep the unit measurement labels that you want that will answer the question, and you want to make sure they're in the right spot. So if you want meters per minute, you need to have meters on top, minutes on the bottom left over. if you want just hours, you need to have hours on the top. So if you only want one measurement, it has to be on the top. Because if hours was on the bottom, if hours was on the bottom, that would be wrong. So we want hours on top. Okay. From experience, the school's Ford Fusion hybrid can get 47 miles per gallon. How much fuel will it take to drive from Lafayette to Fort Wayne? So that's 120 miles. So what we want left over is gallons. How much fuel will it take to drive to Lafayette? Oh, okay. So ultimately, we want how much fuel. So the only thing we want to have left in our equation is gallons. So you want to set it up so that, oops, skip the answer. Jumped right to the second answer. Okay. So 120 miles. 1 gallon is 47 miles. So these cancel out. So now we're left with only gallons, and gallons has to be on top. So how much fuel will it take? We want gallons, and that one needs to be on the top. It can't be in the denominator on the bottom. So once we set this up, as long as everything cancels out and you have left over the unit measurement label you want, you're good to go. So 120 times 1 gallon divided by 47 equals 2.6 gallons. Today's gas prices, oh, well, what are, let's say it's let's say $3. $3 times 2.6 gallons. Oh, I got to do, so $3 per 1 gallon. This is supposed to be down here. Okay, so how much? So 2 point. Yeah, let's do the 2.6 over here first. 2.6 gallons times okay. So we want cost. The use current gas prices to estimate the fuel cost for the trip. So we want to have dollars. No, hold on. Let me get rid of this. There we go. So you want to have dollars left over. So gallons will cancel out. All right, so now we have dollars left over, which is what we want. We want the dollar estimate for this trip. So it's going to be 2.6 times $3 divided by 1, which is going to equal 5.2, no, 7.8, 7.8, $7.8. So this brings up a good point. So instead of using a dollar sign, it probably makes more sense to write dollars at the end so that you don't forget about it. Yeah, so make sure you put your dollar labels at the end like you do with all the other labels. Because if you try to do a dollar sign, you might miss it. It's too easy to miss. All right, so that is that answer if it was $3 per gallon. All right, so this one is tricky. The dollar sign kind of threw me off for a second. Okay. All right, if there are 15,000 gallons of water in your basement, how long will it take the 2,500 gallon per hour pump to pump all the water out. So let's start with our 15,000 gallons. 2,500 gallons per hour, but we don't want 25 on top because gallons have to cancel out. So you want to make sure that you do make sure that you do 1 hour over 2,500 gallons because gallons have to cancel out because the only thing we want left is time. How long will it take to pump the 2,500 gallons? Or I'm sorry, how long will it take to pump the 15,000 gallons out? So we want to be left with just hours. So we want time left. We want to get rid of the gallons. We just want hours. We want to know how many hours. So 15,000 times 1 hour divided by 2,500 equals about 6 hours. Exactly 6 hours, actually. All right, so make sure you have your unit labels in the right spot. They need to cancel out and you need to be left with just the unit label that is the question asked for. And it may ask for something over something like miles per hour, or it may ask for just, time. So then you need to use hours. So that's another thing is if it says how long, that means time, which means hours. The question doesn't specifically say hours. It doesn't say how many hours will it take to pump the water out of your basement. But when it says how long, that means how much time, which means how many hours. So you need to read into the question. Okay. Rates and money. We all love money. Okay. You are planning a party and have a $250 budget for barbecue. You estimate that you will need 2 pounds of barbecue per person, and your favorite place charges $11.75 per pound. How many people can you invite? All right, so this one, the end result, how many people? So we want person left. So person is the only thing we want left. And we want to start with our $250. All right, so this is where it's tricky. The dollars need to cancel out. So the dollar sign makes it a little tricky. It's probably easier to write $1.75. So the dollar signs cancel out. Here we go, the pounds cancel out. And then person is left on top because that's what we want. How many people can you invite? So the only thing we want left is person, number of people, number of persons. So you end up with 250 times 1 divided by 11.75 times 1 person divided by 2. Put that in the calculator, 10.63 people. So in a question like this, you need to overestimate the amount of stuff per person, because if you try to round up to 11 people, that means the last person is going to be 0.37 short. He's going to have 0.37 pounds short of what he wants to eat. So even though 10.63 may entice you to round up to 11, when you have a certain amount of stuff, unless you have 11, you have to round down to 10. Otherwise, somebody's going to get shorted on their 2 pounds of barbecue. So whenever, based on the way the question is written, how many people can you invite? It doesn't say, oh, you need to round it so that no person gets short of 2 pounds, but it's kind of implied. You will need 2 pounds of barbecue per person. So that means you have to have enough so that every single person can have 2 pounds, which means if you round up to 11, you don't have enough because that last person is only going to get 0.37 times 2 pounds short. So in order to get everybody their 2 pounds, you have to round 10.63 down to 10. All right, next question. A quarter barrel of beer is 7.75 gallons and costs $78. Bottles are available in the 12-ounce size, and six packs are on sale for $5.25 each. Which is the better deal if you need a quarter barrel of beer? All right, so another tricky question. Okay, I think we have a typo. So I think this is supposed to say 7.75. So we start out with our 7.75 gallon barrel. We multiply by 122 ounces per gallon, making gallons cancel out. Then we need to convert ounces to bottle. So we got one bottle for 12 ounces. So the ounces cancels out. And then we need to, this is a little tricky, change bottles to six packs. So one six pack equals six bottles. So it might be better to actually write this like this. That way, give me a thin dash. There we go. So, okay, so 7.75 gallons times 128 ounces per gallon. Gallons cancel out. One bottle equals 12 ounces. Ounces cancel out. And then one bottle equals six bottles equals one six pack. So bottles cancel out. So we are left with all right, so it didn't account for price. So is there a continuation? Oh, I'm sorry. There's more to the answer. Okay, so the reason we don't include price just yet is because we have to see how much the six packs, the equivalent six packs would cost. So we do all this, we end up with 13.78 six packs are needed. So 14 six packs. So we need 14 six packs. Then we work on the cost. So 14 six packs times $5.25 equals $73.50, which is less expensive than the quarter barrel at $78. So after doing all this work, we found out that by buying 14 six packs, we will save money. We will save $4.50. Okay, so that was a tricky one because you didn't want to work price in at all until the end because you wanted to find out how many six packs were needed. All right, so let's move on. All right, now we're going to talk about temperature conversions. So the reason temperature conversions are a little trickier is because previously zero centimeters equals 0 inches. 0 inches equals 0 feet. Everything at zero was still zero. So you didn't have to worry about going negative per se. Whereas with temperature, you do. Because 0 degrees Celsius does not equal 0 degrees Fahrenheit. Because 0 degrees Celsius is the freezing point of water, but 32 degrees Fahrenheit is the freezing point of water. So now we have this not just a multiplication issue, but also we have a different 0 point. In this case, if you consider freezing where water freezes as a 0 point, they're different. They're both not zero. Okay, so let's start by breaking this up into pieces. All right, so write the freezing point of water as an ordered pair in Celsius to Fahrenheit. you're gonna end up with 0 degrees Celsius equals 32 degrees Fahrenheit. Now the boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. So if you took those and you graphed them, you would see here's Celsius, here's Fahrenheit. So when it's 0 degrees Celsius, it's 32 degrees Fahrenheit. When it's 100 degrees Celsius, it's 212 degrees Fahrenheit. So there's still a linear relationship. It just doesn't hit 0, 0. So it makes it a little trickier. Okay, so we talked about this y equals mx plus b stuff, where m is the slope. We have 2 points. We want to find the slope. So we want to find when we go from here to here, we go up, rise, divided by run. So the rise from here to here, divided by the run from here to here. So the equation for that is y2 minus y1 divided by x2 minus x1. But if you also just think about it geometrically, we have the rise, which is 212 minus 32 right here. 212 minus 32. And then the run is 100 minus 0. So we're going from 0 to 100 here. We're going from 32 to 212 here. So the rise is 212 minus 32. The run is 100 minus 0. It equals 180 over 100, which reduces to 9 over 5. So now, in a sense, you could replace this with 9/5. And then the intercept, as you can see here, is 32. So the y-intercept is 32. So we found our slope, 9/5. That's the m. That becomes 9/5. And then the intercept, y-intercept, becomes 32. So this is how you would convert Celsius to Fahrenheit. You would plug in whatever degree Celsius here, run it through your calculator, and it outputs temperature in Fahrenheit. Now you also may want to go the other way. So we also have a Fahrenheit to Celsius equation, which just taking this here, and doing some simple algebra, subtracting 32 from each side. Well, let me write that. Right, so I'll do it up here, minus 32. Get rid of this. And then we want to solve for C. So now we have times 5/9. And gets rid of this. So that's how this equation came from the other equation, 5/9 times f minus 32. Let's put that back. Oopsie, shoot. Okay. So we have 2 equations, one that goes Celsius to Fahrenheit. You plug in the Celsius, it gives you the Fahrenheit. This one, you plug in the Fahrenheit, it gives you the Celsius. All right, you get sick while in Montreal, you go to a clinic. The nurse says, your temperature is 38 degrees Celsius. Should you be concerned? So you want to take our Celsius to Fahrenheit conversion, because you're going to plug in 38 degrees Celsius here. So you just plug in 38 here and run that into your calculator. And you get 100.4 Fahrenheit, which is a slight fevers because you should be 98.6. I wouldn't be too concerned about 100.4. It's not that bad, but it could be getting worse. So it's worth monitoring. All right, you want to convert a comfortable room temperature of 72 degrees Fahrenheit to Celsius. So that's this one. We want to plug in the Celsius or the Fahrenheit. We want to plug in the Fahrenheit, the 72 here, and figure out what that is equivalent to in Celsius. You plug that in, 72 for F. You run it through your calculator, 22.22 degrees Celsius. I feel like 72 is a little bit hot for a room. I feel like 70-ish. I guess everybody's different. Okay, this is important. You need to refrigerate your potato salad at 39 degrees Fahrenheit, otherwise it'll become poisonous and deadly. So you want to convert Fahrenheit to Celsius. So you use this equation right here. You plug in 39 for F. I'll show them both. Plug in 39 for F, run that into your calculator. You get 3.9 degrees Celsius. When you punch these in your calculator, make sure you use parentheses because the calculator has a specific order of operations. And if you do not do it in the right order, you may end up in trouble. All right, currency conversions. I think this is the last thing we're going to talk about. Oh, and then, yep, so this will be the last thing. Okay. All right, so these are your currency conversions. 1 euro is $0.9825, or $1 is 1.0178 euros. So $1 equals 20.44 pesos, or 1 peso equal, I'm sorry, $1 equals 0.0489 pesos. And then there's 20.44 pesos in a dollar. I know that a peso is about a nickel. So it's about a 20th of a dollar. Okay, so we're going to do that same thing. We're going to use these identity ratios. All right, so you have euros to US dollar. You're going to use 0.9825 over 1 or 1.0178 over 1, depending on what you want to use. Well, either conversion can be used, which is more convenient. Most people are going to like multiplication better, but that's either one works just fine. All right, you get an internship in Madrid. You take $500 spending money with you. How much euros can you exchange for this? All right, so you have $500. Again, this makes more sense to do dollars. All right, so now you take this, these cancel out, dollars cancel out. So we use this one here, the euro and the 1 euro to 0.9825 US dollars. Dollars cancel out, so you're left with 500 times 0.9825 euros. And euros is what you want at the end because you want to know how many euros your $500 is worth. All right, as you leave Madrid, you convert 350 euros to US dollars. How many dollars do you receive? You're going to use this one, euros over US dollars. Or I'm sorry. Euro. Oh, they're using this one, but they flipped it because you want, it just makes it a little easier to do that way, I guess. So euros cancel out. So you can use either one of these. The issue is that with this, you don't have to deal with 0.9825 on the bottom or something like that, or you'd have 0.9825 on the top and then 1 euro here. So either one of these works. Just make sure the euros line up so that they cancel out. And then you're left with dollars. So 350 times $1.0178, $358.6 $23. So that's what you want. You want dollars at the end. All right. You have pesos, 2,000 pesos. How many US dollars is that? Use the conversion to pesos. Set it up so that pesos is on the bottom here so that it cancels out and you're left with dollars being your only unit label. So 2,000 times $0.0489 equals $97.80. McDonald's Big Mac in China costs 21.7 yen in July of 2022. How much is this in US dollars? Okay. Use our yen conversion. Oh, I'm sorry, not the yen. Yen is Japanese. I'm not sure how to pronounce this one. Yuan? Yuan? Chinese. Let's say Chinese currency. That's dollars. All right, so you make sure that these are lined up so that they cancel out. 21.7 times $0.1494 leaves you with just dollars, $3.24. You can get a reasonable meal in Japan for about $10. How many yen is that? All right, so we start out with $10. Oops. Set it up so that set up the conversion so the dollars is on top here and then it's on the bottom here. So that leaves us with just yen. That's what we want. We want yen. So 10 times 136.16 yen equals 1,361.6 yen. You're on a train from India to China and want to know how many yen? It's not yen. You will be able to get for 10,000 rupees. All right, so this one you're going to have to do multiple because you're going to have to go here to US dollars and then to India rupees. Oops. Okay, so you set it up first. You change your rupees to dollars. Those cancel out. Now we set this up so that our dollars cancel out. And we're left with the yuan. I should have looked this up before, looked up how to pronounce this before I did this recording. Yuan, call it yuan. So the rupees cancel out, the dollars cancel out, we're left with the yuan. So 10,000 times 0.0126 times 6.6945 yuan equals 844. All right, so which is more expensive, a jacket that costs 50 US dollars or a jacket that costs 50 Australian dollars? All right, so let's set this up. So $50 is 1.4582 Aussie dollars. So these cancel out, which leaves us with 50 times 1.4582 Aussie dollars. Aussie dollars is what we want at the end. So it's 72.91 Aussie dollars. This is more than the 50 US dollars. So this is more than enough. Okay, so our 50 US dollars. All right, so this gets a little tricky. Jacket that costs 50 US dollars or jacket that costs 50 Australian dollars. So our 50 US dollars is equivalent to 72 Aussie dollars. So that means that 50 Aussie dollars is less than our 50 American dollars. So the Aussie jacket is cheaper. So it's more expensive in the US. So that's a tricky question right there. because 50 US dollars equals 72 Aussie dollars. So if the jacket is 50 Aussie dollars, that means that the $72 in Australian money that would buy a jacket in the US now leaves you with $22.91 Aussie dollars left over after you buy the same jacket in Australia. So the Aussie dollars get you more. Like you buy the jacket, then you still have money left over. So the Aussie dollars jacket, the jacket bought with Aussie dollars is cheaper. Okay, so that is the end of the lesson. What I have though is you should have handouts, and I will put the handouts on Ivy Learn, so you'll have them there as well. I'll send out a announcement. So the announcement will have the handouts you need to work on. So basically, you have a handout. It's going to have you do a lot of the stuff we just went over for the last hour and a half or so. I want you to complete that. Stay here and work on it for a little bit. But whenever you get far enough into the handout that you feel like you can leave, it's late enough, you can go ahead and leave. So hopefully whoever is there passed out a sheet for you all to sign so I can get an attendance. So if you haven't done that, sign the sheet so you're on the attendance list. And then work on the handouts that will be on Ivy Learn and should be handed out to you right now. If they're not handed out right now, go to Ivy Learn. You can look at it and just write it on regular paper. So work on that for a little while, and then once you get far enough in, you can go ahead and go home. All right, thanks you all. I hope this recording helped. I know I'm not there, so I can't answer questions, but this is about the best I can do. So hopefully this recording helped you out, and then email me with any questions. And you all have a good night.